Hi, and welcome to the segment of math exam questions on algebra and algebraic fractions. Question 3. Factorize the given expression. This is achieved by extracting the common factor y, making the expression into a product of y and 5 minus 6p. Question 16a. Expand the given expression. This is the reverse of factorize, and it would change the expression to being x cubed minus 7x squared. Next, factorize the given expression. The factorization takes the expression to being y times y plus 1. Question 23. Rearrange this formula to make x the subject. For the rearrangement of this formula, you apply BODMAS in reverse order. For this specific equation, you'll start by acting on operations in relation to addition and subtraction to get to the second line of the working. Then, those in relation to multiplication and division to get to the third line of the working. And finally, that in relation to orders of a number to get to the final answer. Question 9. Simplify the given expression. By summing the x and y elements independently, it gets us to 14x plus 13y. Question 14. Rearrange the equation to make y the subject. Again, for any rearrangement, we'll be needing to act on BODMAS in the reverse order. For this given equation, you start by acting on the operation in relation to multiplication and division, then working on those that are in relation to the brackets. Next, solve for the given equation. In the rearrangement, x is 3. Question 6. Solve the stated equation. Again, by acting in the reverse of BODMAS, the rearrangement will get us to f being equal to 2. It is good practice to reinsert the value of 2 into the equation to confirm its correctness. Question 12. Simplify the stated expression. Here, the numbers would multiply to 10, and the orders of m would add to 5. Next, simplify the expression on 12b. In such a situation, the orders would multiply, taking x to the order of 24. Question 17. Write as a single fraction in its simplest form, the stated expression. When performing the addition or subtraction of fractions, we will need to equate the denominators. And in getting to its simplest form, we would need to be expanding on all necessary. Question 19. Rearrange this formula to make m the subject. Do note that m appears in 2 places in the equation, and by rearranging m per the working, it should lead m to being equals k divided by p minus 1. Question 17. Factorize the given expression. Its factors are p minus q and p plus q. Next, if p squared minus q squared is 7 and p minus q is 2, find the value of p plus q. P plus q is the division of 7 by 2. Question 18a. Simplify the expression. The correct answer is 27y to the order of 12. Question 18b. If 2 to the order of 3 is equal to 4 to the order of p, find the value p. By restating 4 as 2 to the order of 2, 2p can be expressed as equal to 3, and therefore p is equal to 3 over 2. Question 20. Write as a single fraction in its simplest form the stated expression. Again, you will scale both fractions such that the denominators are the same. Then expand and simplify to get to the required simplest form. Question 14. One solution of the equation is when x equals 7. Find the value of a. By making x equals 7 in the equation, you can then solve for a as being 3. Next, find the other solution. By equating a as 3 into the equation, we can then solve for x, with the other x being minus 7. Question 16. A is equal to b times h over 2. A is 10, correct to the nearest whole number. H is 4, correct to the nearest whole number. Work out the upper bound for the value b. For what is required, we have to make b the subject, making b being equal to 2a over h. For the upper boundary for b, we have to identify the upper boundary for its numerator and the lower boundary for its denominator. With a being 10.5 and h being 3.5, we can identify the upper boundary for b as being 6. Question 17. Simplify the expression, giving your answer as a single fraction. In this case, you could factorize its numerator to being the product of x squared and x plus 5, and its denominator to being a product of x minus 5 and x plus 5. By removing the x plus 5 from both its numerator and denominator, the simplified expression becomes x squared over x minus 5. Question 9a. Simplify the expression. The simplification should take us to 6a plus 4b. Question 9b. Calculate the value of 4x squared plus xy when x equals 3 and y equals minus 2. We should arrive at 30. Question 9c. Solve these equations. X over 4 being equal to 20. X comes to 80. Next, solve the equation of 3x minus 5 equals 16. By doing the math, x equals 7. Question 9c3. Solve the stated equation. In going through the working, x is 2.2. Question 9d. Make r the subject of the stated formula. By rearranging the equation, r is p plus 5 divided by 3. Question 7a. S equals ut plus half at squared. Rearrange the formula to write a in terms of ut and s. Again, by doing BODMAS in reverse order, you'll be able to get to a being as stated. Question 6b. Factorize completely the first expression. This factorization involves identifying common factors. Next, factorize completely the second expression. In this case, you would factor the first portion and the second portion independently to arrive at the answer. Next, factorize completely the third expression. This is a variation of x squared minus y squared being a product of x minus y and x plus y. Next, solve the stated equation. By doing the math, x is 5.5. Question 2b. Find the integer values of n that satisfy this stated inequality. For such a question, you would scale the for n to being n to ease in identifying the answer. That's all for this segment. Do get into our other videos under KT Tutorial channel if you've liked this.